Hello, stats children. I'm Mrs. Brissett. I understand you're very upset that I am not with you, and I kind of understand that, but we haven't met, so I don't know you and you don't know me. So it's a little weird that you miss me, but you don't know me. But anyway, just food for thought. Okay, so today we are going to start. I have lessons recorded from this chapter, chapter 3, all the way through chapter 5, and that's where I've decided to stop you this semester. So guys, you just done chapters 1 and 2. We're going to start chapter 3, which, as you can see, is all about scatter plots. Microsoft Word. We'll talk about that. So chapter 3 is all about scatter plots. Chapter 4 is all about how to take samples and how to do experiments. And then chapter 5 is probability. And that's where you're going to stop this semester. So I'm going to go through and actually fill out your notes with you, but also lecture at the same time. As you obviously know, this video is available on YouTube, so if you listen to this in class and it didn't really make any sense, you are, of course, more than welcome to try this again at home or wherever, in AP Gov or just what have you. Just, Markite's drones on, blah, 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 blah. Just throw in a couple of headphones and listen to an AP Stats lecture. I'm just saying. Anyway, before we get into scatter plots, though, I have a quick public service announcement for you AP Stats kids. So I hear, by the way, it's September 19th. I wasn't originally going to record chapter 3, but I hear you're in dire need and crying, and my preemie son still sleeps a lot, which is great. It's just he doesn't sleep when you want him to sleep. But anyway, so I have a little time. I'm recording these lessons for you, and that's pretty much all I can do for you. But quick public service announcement to make you feel a little more confident. I hear from other teachers and I hear from ex-students who've graduated that y'all are a little riled, if you will, a little worried. And I totally get that. But I just wanted to kind of talk you through where I'm at with AP Stats. So just to give you an overview, this is heartbreaking, but go with me. The entire first semester of AP Stats, guys, is kind of like an introduction to stats. In real college statistics, the whole first semester of AP statistics is like a week and a half. I'm not kidding. The really important stuff happens second semester, and coincidentally, the really hard stuff happens second semester. So if you're kind of worried about, okay, I'm not sure, I don't really have a good textbook, I don't really learn very well from recorded lessons, I get you, but we're going to do the hard stuff together next semester. So don't worry so much about that. Second thing, almost everything we do this semester, not everything, but almost everything we do this semester, so that's chapters 1, 2, 3, part of 4, sum of 5, we're going to revisit next semester. It just naturally folds into the curriculum there too. So if you didn't quite get the stuff this semester, that's okay. We're going to see it again next semester. And again, I will be there physically for that. Next, as far as the rest of this semester goes, chapter 3 is about scatter plots and linear regression. It's a medium. It's not an easy. It's a medium. Chapter 4 is about samples and experiments. That's easy. Guys, you know how an experiment works. You've been doing experiments since you were in 4th grade. And really, we're just adding some vocabulary to what you already know. So chapter 4 is easy. Chapter 3 is medium. Chapter 5, unfortunately, is probability. And it's the same probability that you have worked with before. So if you were good at probability in the past, chapter 5 most likely won't be that bad for you. It'll be like a medium. If you sucked at probability in the past, chapter 5 is going to be rough. And so I get you, that's okay. But the good news is the entire nation, I'm not kidding, sucks at probability. Every year on the AP test, kids always score badly on the probability section. So even if you don't get chapter 5, if you don't get the probability section, nobody else does either. So you're good. Finally, Khan Academy. Guys, I've checked out the Khan Academy AP Stats stuff. It's good. Like that's AP Stats. That's legit. So if you didn't catch chapters 1 or 2, like you had some trouble with it, and you are serious, if you are serious about passing the AP test, you can go back and kind of check out those videos and see just kind of see what they do, see if it helps you, see if it makes sense. Because that material is pretty much what I would do. The only difference is with normal CDF. If you know what I've just said to you, if you recognize the term normal CDF, that's great. He does it a little differently than I would do it, but the rest of everything I've seen for those chapters are solid. So all of that to say, guys, I know you might be worried about how you're going to do on the AP test, and you shouldn't worry. I'm not worried about it. If you're serious about AP stats and you want to pass the AP test, you will pass the AP test. So let me clarify that, and then we're going to get started. If you want to pass the AP test, you will pass the AP test. Now, here's what I didn't say. If you would like to pass the AP test, you will pass the AP test. Guys, we all would like to pass AP stats. We all would like that. But you got to actually do some work to get it. And so I would like for all of you to pass AP stats, but I know that not all of you, second semester of your senior year, are going to want to put in the work. But guys, I'm telling you, if you do put in the work, you will certainly pass the AP test. So to be successful, here's my suggestion. Take these videos seriously. Actually do your homework yourself. Yes, that's correct. And if you get to a problem that you're stuck on, go to Slater. Look at what they did. See if you can make sense of it. That process of going to Slater and looking at a problem and saying, oh yeah, I think I know what they did. Guys, that's learning. That's fine. You with me? But if you sit here this whole semester and say, she's not here, I don't know what to do, then you're probably not going to pass the AP test. If you pass this off, if you say, well, it's not my fault, you're passing off responsibility. I get that. Like, I totally understand that. I absolutely understand that. It is super frustrating that I'm not there. But if you're 100% relying on me to understand this, you're probably not going to pass the AP test because I can't be with you in the AP test. I can't tell you what to do. So if you're serious about this, be serious about this. Actually try to learn from these videos. Actually do your homework yourself. If you have questions, go to Slater and look at the answers they give and see if they make sense. And if not, talk to other kids in the classroom. Guys, you are smart. This is Edison. You guys can figure this out. Okay? So really, don't worry about the AP test. Unless you have no intention of exerting any effort whatsoever, then you can go ahead and worry about it because it's not going to happen. All right. Hopefully you feel better. Hopefully you got a taste for me. I'm sassy, by the way, just in case you couldn't tell. So let's get this going. Let's do it. Scatter plots. And yes, this is the scatter plots that you probably already are familiar with. So let's go for it. So we have a couple of terms. So in scatter plots, those are the things that look like this, where I have a little X and Y axis, a bunch of dots all over the place. They don't make a straight line. They don't make a perfectly aligned curve. They're just sort of scattered. Okay. So some terms to define before we kind of get into actually making a scatter plot and what they mean and what you can glean from them. A response variable. This is almost always going to be, not almost always, it is always on the y-axis, so that's your y variable, and it's basically the outcomes in a study. So if I do an experiment on, I don't know, puppies, and I shampoo a bunch of different puppies with a bunch of different puppy shampoo, the amount of shine in their coat would be my response variable. It's what I'm measuring, okay? So these are the outcomes, which is what is actually measured. In a study. Forgive my ugly handwriting on this computer. Oh, also pause, disclaimer. I have to record this partially in Microsoft Word, which sucks. So it does stupid things like it'll move like a Y to a different part of the page. When that happens, I usually get frustrated and I don't curse, but I like say things like, gosh dang it, that kind of thing. So I'm really sorry, but word is really, really frustrating. Secondly, I'm doing this at home. My dog really doesn't like trucks, and so anytime they drive by, you're going to hear my dog bark. Sorry. And thirdly, I have a child who's currently sleeping, but when he wakes up, his cries kind of sound like a pig. So just so you know. All right, so we have a response variable, which goes on the y-axis, and then, of course, as you may guess, the explanatory variable goes on the x-axis. And from the name explanatory variable, you may have gotten that the variable on the x-axis can, not necessarily does, but it could help explain the changes in the y. So the way we're going to say that is the explanatory variable may help predict or explain changes in the response variable. So that's your explanatory and response variable. Your explanatory variable would be your x variable, and your response would be your y variable. Now, in certain situations, these can be interchangeable. So these could be interchangeable. So an example of that would be, what if I made a scatter plot that graphed, I don't know, height and shoe size? So I take every single person in this room, I make you guys measure your feet length, and then I graph that with your height. So let's say in our little mini scatter plot here, somebody with a height of 6 feet maybe has a foot length of, actually I have no idea what a rational foot length would be. Let's say 15 inches. And so that would be height and foot length. So in that case, what I'm saying is I can use your height to predict your foot length. And so if you're 6 feet tall, presumably you're going to have a longer foot length than somebody who is 5 feet tall. So in that case, I'm using your height to predict your foot length. But I could just as easily switch those and make this, and make this height and this foot length. And the way that would work is I would take somebody, let's say I take a dude with a size 13 shoe. Well, could I use that shoe size to predict their height? Well, sure. If you have a size 16 shoe or whatever I said, you have a huge foot, which means you're probably a big guy. So you're probably pretty tall. So in that case, and in some cases, not in every case, things like height and foot length could be interchangeable. One could be the X, one could be the Y, or you could switch them. Because in either case, you can use both to predict the other variable. So in some cases, these are interchangeable. Just kind of keep that in mind. So let's check out a problem. I'll have you guys try it real quick, and then we'll check it. So here's how kind of examples and stuff are going to go. So I'm going to have you read through an example, and then I'm going to ask that you pause this video, you actually try the example, and then you press play, you resume, and see if you got the answer right. A lot of this stuff, guys, is pretty easy. So let's go for it with this example. So we have the following. Identify the explanatory and response variables for each of the following situations. Part A, Julie asks, can I predict a student's math score if I know his or her SAT reading score? Part B, Jim wants to know how the SAT math and SAT reading scores are related to each other. So in both of those situations, for Julie, what does she think is the explanatory and response variable? And then for Jim, what does he think are the explanatory and response variable? So go ahead and pause the video right now, actually write down an answer, or discuss if you don't want to write it down, if you don't want to commit to that, I understand. Discuss what you think the answer would be, and then check it. Okay, so pause. I'm going to keep going though. Okay, so for Julie, she wants to predict an SAT math score from an SAT reading score. And so since she's using the reading score to predict the math score, the explanatory variable here is the reading score. So explanatory would be SAT reading. And then response would be SAT math. And again, I know this is explanatory because she's using the reading score to predict the math score, just like we used foot length to predict height. So that's for Julie. For Jim, it doesn't really seem to say which one he thinks he could use to predict the other one. He just simply wants to know how these two are related. And so in this case, he doesn't really say which one is explanatory or which one is response. So it could be either one. And by the way, if you're doing a problem and you're being asked to, for example, make a scatter plot, if the problem doesn't explicitly say which variable is explanatory and response, then it's up to you. You get to kind of pick. It really doesn't matter which one you choose. For me personally, I always pick the very first variable they list because I like to kind of have a system. But it really doesn't matter if the problem doesn't state it. However, for Julie, her problem did say she's using reading to predict math. So in this case, if I'm making a scatter plot from Julie's information, the SAT reading would have to be on the x-axis and the math would have to be on the y. Okay, so let's check out the next problem, which is, by the way, gonna ask you to make a scatter plot. Okay, so here we go. The Southeastern Conference traditionally has some of the best teams in college football. When looking at the 2011 college football season, here are the average number of points per game and number of wins for each of the 12 teams in the SEC. And so we have a little table here. It shows points per game on the top and then wins on the bottom. And they would like you to create or make a scatter plot of the relationship between points per game and wins. Okay. So in a second, I'm going to have you pause the video again and actually make the scatter plot by hand. Oh, yes. Oh, yes, yes, yes. And then we'll talk about other stuff. But before that, let's use what we just learned. So we have two variables. We have points per game and we have wins. And we need to decide which is explanatory and which is response because we need to figure out which variables to put on the X and Y axis. So pause this for a second. They listed out points per game and wins. Which do you think could predict which? Or could they kind of predict each other? So pause and discuss that for a second. Okay. So I don't know what you came up with, but actually they could kind of predict each other. So for example, Alabama, let's check out Alabama. Alabama had 12 wins and they averaged 34.8 points per game. That's a lot of wins and that's a lot of points per game. Versus Mississippi, poor Mississippi, only had 2 wins and they averaged 16 points per game. So here's the deal. If I tell you that a certain college averaged 40 points a game, can you predict the number of wins they would have? Well, yeah, they'd probably have a lot of wins. So I can use points per game to predict wins. But I could also use wins to predict points per game. If I tell you that a team won only 1 game, you would predict their points per game would be pretty low, maybe like 10 points per game or something. So either one works. So in this case, it really is completely up to you to choose which one's explanatory and which one's response. And for me, I always choose the first variable to be the explanatory and the second one to be response. But you could easily have switched that and that would be totally fine. So I would like you guys to pause the video now, go ahead and make your scatter plot. And when you press play again, you should see my completed scatter plot as well. Pause. I obviously can't ask you questions, but I'm assuming maybe a couple of you might want a refresher on how to make a scatter plot. So let's do that. On the x-axis is our points per game because that's what, see what this did to the O? I hate Microsoft Word in the face. Okay, so I'm going to put points per game on the x-axis and I'm going to put wins on the y-axis. Now scatter plots, totally up to you. You don't have to start at 0. You don't. So you could start at basically wherever the data picks off. Now, for me, actually, let's see what I did in my original here. I did not start at 0 for the points per game. So for me, the points per game, the lowest points per game is 15.8, and I'm going all the way up to, I think, 36. So what I'm going to do is I'm going to label the x-axis. I'm not going to start at 0. I'm going to start at 15. And I'm going to go up by 5. So 15, 20, 25, 30, 35, and 40. And then because number of wins basically starts at 2 and goes to 12, I can go ahead and start at 0. And then I'm going to go up by 2. So 2, 4, 6, 8, 10, 12. I guess I didn't have to squish those together, but that's okay. 14, 16, 18. Okay. So first I'm looking at my values and I'm deciding how to label my graph. Next, let's say I wanted to, we'll change colors for this. Uh-oh, my pig son is waking up. Uh-oh. Come back. There we go. Okay, so let's say I'm checking out Alabama. So I want to graph Alabama's information. So they have earned 34.8 points per game, so that's around 35, and they've had 12 wins. So I'm going to go to 35 and go up to 12 approximately, go a little less than 35 and put a dot. So that dot is going to represent Alabama. So that's kind of how you would make the scatter plot. Go ahead and pause the video, draw your scatter plot, and then compare with mine. Okay. So your scatter plot should look something like that, with your points kind of heading in a positive direction. So let's talk AP for a second. So part of what they're going to ask you to do occasionally is make a scatter plot. Most of the time they'll just give you the scatter plot. But once you've made the scatter plot, as you may have noticed from chapter 1, you make a graph, you describe the graph. You make a graph, you describe the graph. And so we are going to do the same thing. So if you flip over to the next page, they ask you to describe the association. Whenever they say describe the association, they mainly mean graph. Where'd the G go? That's weird. Okay. So describe the association, describe the graph between the number of points scored per game and the number of wins for SEC teams. So if you want to pause the video here, that's fine, and discuss what you notice. I am guessing that whatever you naturally come up with are exactly what you should talk about. So go back up to the graph, talk to your group, describe the association, describe the graph that's showing the relationship between points per game and wins. So pause, go ahead and do that, and then check back with me. Okay. So I'll talk you through and then I'll write down what I want you to say. But what most of you should have come up with is, it looks like the higher the points per game, the higher the number of wins. If that is a point you came up with, that's huge. That does two things for us. If you notice, these points are headed in a positive direction. Direction is something you're going to have to talk about with scatter plots. And you mentioned that. The higher the points per game, the higher the number of wins. That you're insinuating direction. Meaning, as these numbers get bigger, those numbers get bigger. So there's a positive association. And then also you added in context. The higher the points per game, the higher the number of wins. On an AP test, if they ask you to describe a scatter plot, there are 4 things they're looking for, and you just nailed 2 of them. One of them is direction, and one of them is context. So if you said that, sweet. The next couple things you're going to want to talk about is how good is this scatter plot looking? Meaning, how close are these points together? Like, are they all over the place? Is this a blob, or is this a pretty clear pattern? And for my money, I'm going to argue this is a pretty clear pattern. Most of these points are kind of in line. Now, they're not perfectly in a line, but they're pretty close. They're pretty constant. So you've talked about 2 things. You've talked about context. You've talked about the direction of the points. And the next thing you're going to want to mention is strength, which is most of these points follow the pattern pretty closely. They're pretty close together. Don't draw the circle on your scatter plot. I just did it for effect. So hey, look at me. So you've talked about direction, you've given context, and now we've talked about the strength of the pattern. Next, we've got to talk about the form. Now, we kind of already called it, but how are these points grouped together? Are they grouped in sort of a curve? Are they kind of making a line? I would argue they're making a line. If I can kind of draw a line through the middle of the data and pretty much most of the data stays close-ish to that line, then the data is what we call linear. Data that isn't linear, for example, would look something like this. If you notice, that kind of makes a bowl. It should remind you of a parabola. This data is not linear. In fact, it's quadratic. It's a parabola, parabolic, if you will. But the data from the SEC wins and points per game, that's linear. So we've now talked about 4 things. We've talked about direction with context. We've talked about form, if this is linear or not, and we've talked about strength. How close are all of these points together? Are they pretty close together or are they not? And then the last thing that we normally talk about with any graph is, hey, are there any outliers? And so we'll talk all about outliers and how they could look, because they're sort of a weird idea for scatter plots. But first, let's actually write down everything you would need to write down for an actual AP question, okay? So what I would say is, ooh, my goodness gracious, Microsoft. Okay, so I would say from the scatter plot above, it appears the more points per game a team has, the higher the number of wins. And this is a positive association, and we'll talk about what that means in a second. So from the scatter plot above, it appears that the more points per game a team has, the higher the number of wins. The plot has a fairly strong linear pattern. And that's because most of those points stay in a line-ish, and they're pretty close together. And then finally, let's talk outliers. Ooh, can I undo that? How do I undo without a keyboard? I'll just move it back. There we go. Okay. So let's check out our scatter plot here. So I'm going to argue this scatter plot really doesn't show many outliers, but if you were to argue that there were a couple of outliers, you would probably look at these two. I would argue they're not outliers. They're not far away enough from the rest of the data, but that's sort of up to you. And if you argued that those were outliers, I would be okay with that. But a couple of things. In a scatter plot, let's talk about what is and is not an outlier. Okay, so we got this guy, one up here, one down there. So as you sort of notice, the darker red dots that I've drawn are for a purpose. I would argue any of these really are outliers. However, not all outliers for scatter plots are created equal. So pause this for a second, discuss with your group. One of these 3 outliers is more intense of an outlier than the others. So discuss with your group, which outlier do you think that is? That's right, kids, it's this guy. And the reason why this outlier is a little more intense is because these 2 outliers are away from the rest of the data. Most of the data is here in the middle. But if you notice, those 2 outliers are still in line with the rest of the data. They're still following the overall pattern of the rest of the data. So all this means is these 2 particular outliers were just extreme outliers for only one of the variables. And in fact, they look like extreme outliers for the y variable. So what that means is if you had a bunch of data like 1, 2, 3, 10, and then you had one, let's do this. And then I had like 0.5, 0.6, 0.7, and then 1.2. So if this is the data you had, if you had X and Y data, or actually I said X, or I said Y, but it's actually both. So if you had X and Y data, if you notice, you have numbers 1, 2, 3. Those are all together. They all kind of follow a pattern. And then 10 is out there, and that's a crazy outlier. But for the Y variables, again, you have 0.5, 0.6, 0.7, and 1.2, also crazy out there. But if you notice, as these numbers increase, so do these numbers. And the 10 and the 1.2 continue to follow with that pattern. So what this outlier would look like would be something like that point. It would be way out there, but it would still follow the pattern of the rest of the data. Versus this outlier, I'll make him blue, would be something like 11 and 0.3. So the 11 is also pretty far out there in the X direction, but the 0.3 doesn't follow the pattern of the rest of the data. It's way too low, because as these numbers have been increasing, those numbers have been increasing. But 11 and 0.3 doesn't follow that pattern at all. So all of that to say, when I'm looking at outliers in a scatter plot, you have two types. And we're going to get more into the vocabulary with that later. But you have outliers that are in line with the data, and then you have outliers that are not in line with the data. In this case, for our points per game and wins, we have two potential outliers, but they're in line with the rest of the data. And for my money, they're not that far away from everything else. So I'm going to go ahead and just say there does not appear, there does not, or there do not appear to be outliers in this data. Okay, so let's talk about what we just wrote in pink. This first sentence covers one of the things I want you to talk about, which is direction. This second sentence, fairly strong. This covers strength, which I also want you to talk about, and linear covers form. So we talk about form, direction, strength, and then if there are outliers, you're going to mention them. Oopsie, whoa. If there are outliers, you're going to mention them. If there are not outliers, you are not. So we have direction, we have form and strength. And then if there are outliers, you're going to mention it. Okay. So let's kind of break this down into a little more detail for other problems you might see. And then I'll show you how to create a scatter plot on your calculator. Okay. So form. We are describing scatter plots by commenting on form, direction, and strength, and the relationship between X and Y in context. If you haven't noticed this yet, you're going to notice it now. Everything you talk about has to be in context. So you can't see a scatter plot and say, it's positive and fairly linear. That covers direction, form, and strength, but there's no context. So that would get you like no points. So for form, basically all we care about in this class is it linear? If not, is it curved? Is it a blob? What's going on? Is there no pattern? That's really what we care about with form. Direction. So as the X variable increases, what's going on with the Y variable? So as X increases, what's happening to Y? So if as X increases, that leads Y to increase. So if as X increases, Y increases, this is a positive association. and it's going to look positive because associations. Sorry. Association. So it's going to look like that. And then if as x increases, y decreases, that's a negative association. So that's going to look like that. So for direction, you want to talk about, hey, as the x variable is increasing, what's happening to the y? You don't even actually have to use the words positive and negative. What they want to hear is stuff like, as the number of points per game increases, the number of wins increases. As the number of, I don't know, as the height increases, the foot size increases. That kind of thing. So they're more interested in that type than in the words positive and negative. Microsoft, I hate you. Okay. So moving on to strength. How strong is the pattern? How strong is the pattern shown? Do most points follow the pattern? If they do, then you have a strong relationship. If they don't, then you have a weak relationship. And we'll talk all about, well, what counts as strong, what counts as weak. And then finally, outliers are points that don't follow the overall pattern. And as we discussed, there are two different types. Okay, and so we have a bunch of data here. This guy is an outlier, that guy is an outlier, that guy would be an outlier. So any of these three would be outliers. And not all outliers are created equal. Okay, so that is my intro to scatter plots. You hopefully know how to make them by hand. Now you know specifically what we're looking for to describe them, which is form, direction, and strength, outliers if there are outliers, and then put this in context. So again, if you're unsure, going back to this description up here is a pretty good picture of what we're looking for when they ask you to describe scatter plots. Finally, I'm going to show you how to create a scatter plot on the calculator, but I will sort of disclaimer a little bit. Say this, and this should actually be, mine's on the next page, but yours should be on the same page. Most of the time, if on the AP test they ask you to make a scatter plot, most of the time they don't give you a ton of data, and so it is easier to make a scatter plot by hand. So if you only have like a set of 10 numbers, 10 x's, 10 y's, just make the scatter plot by hand. If they give you 50 x's and 50 y's, then of course, go ahead and plug it into your calculator. Okay, so here are the directions for this. So first, you have to put your explanatory variable numbers into L1 and your response variables into L2. So for example, if you're we'll use the stuff from up there. If your X list is 1, 2, 3, 10, and your Y list is 0.5, 0.6, 0.7, and 1.3, then you're going to need to make sure to put your X variables in L1 and your Y variables into L2. And you need to make sure there's an equal number of each in L1 and L2. So that in this case, there should be 1, 2, 3, 4 numbers in both lists. Okay? So they have to match. If you have 4 in your X variable or 4 in L1 and 5 in L2, your calculator is going to give you an error. So next, to make a scatter plot, you're going to press second and y equals. And hopefully you know how to get to L1 and L2. That's kind of a big deal. So to get to L1 and L2, you press stat and then enter. You should know that by now. And if you don't, again, guys, all of this is Googleable. So if you're like, I don't know how to make a scatter plot, guys, why do you have your phones? People, grab your phones, Google how to make a scatter plot with a TI-84 or whatever. Like, there's tons of YouTube videos that are going to do a way better job than I will right here. But here we go. So second y equals, and then press enter. Oops, I don't know why I wrote a second e. Okay. And that's where you're choosing your graph type. So step 3, you're going to go down to type. And you're going to go to the very first icon, which actually looks like a little mini scatter plot. So go to first icon and select it. Okay. And then once you do that, once you select that icon, it should automatically ask you for an X list and a Y list. Uh-oh, baby's angry. I'm almost done. You want to make sure your X list is L1 and your Y list is L2. If either one of those are not L1 and L2, to actually type in L1, you're going to press second and the number 1. And then for L2, it's second and the number 2, if they don't already say L1 and L2. Okay. And then finally, once that's done, you're all set up and ready to go. So to see the graph, you're not going to press graph. No. You're going to press zoom. And then you're going to choose the selection number 9, or you can literally press zoom and then literally go to the 9 button and press 9. And then once you do that, it should show you a scatter plot. It should all be together. It's not going to necessarily show you numbers unless you have a fancy calculator, but if you want to see the numbers, you're going to press trace. Okay. So all of that to say, this is the intro to scatter plots. I know this video is really long, but that's because of my rambling public service announcement in the beginning. Normally they're not this long. All right, people, have a lovely day.